December 7th, 1941, 7:55 a.m. Radio room of Ford Island Naval Air Station, Pearl Harbor, Hawaii, USA. Charles H. Kelly, a U.S. Navy radio technician, was bending over to adjust the RT-12 radio transceiver in front of him. His fingertips glided across the body covered with brass terminals, and his ears were filled with the steady, hissing current sound of the equipment in operation. This familiar noise was the most reassuring background sound during his duty, but at this moment, a devastating surprise attack was rapidly approaching through the morning fog of the North Pacific. Without any warning, a deafening explosion suddenly shattered the tranquility of Pearl Harbor. The shock wave, like an invisible giant hand, slammed fiercely against the reinforced concrete walls of the radio room. Kelly's body jolted, and the adjustment tool slipped from his hand, clanging onto the concrete floor. Himeng-D looked up, and through the dusty glass window, he saw three Japanese Mitsubishi A6M0 fighter planes marked with the rising sun flag, skimming low over Ford Island. The aerial bombs under their wings detached from the racks one after another, plunging toward the battleship anchorage not far away. Before the huge splashes from the bombs hitting the water subsided, violent explosions roared again, and thick smoke, like black mushroom clouds, rose from the deck of the battleship USS West Virginia, quickly covering half the sky. Following closely behind were Japanese torpedo bomber formations. Type 97 carrier-based attack planes flew ultra-low over the sea surface, their wings almost brushing the waves. The torpedoes under the fuselages plunged into the water the moment they left the planes, trailing white wakes as they accurately rushed toward the unsuspecting U.S. warships. Boom! Another loud bang. The side of the battleship USS Oklahoma was hit by a torpedo, and its thick armor plate was torn apart like paper. Seawater rushed into the cabin frantically, and the hull tilted at a visible speed. Sailors on the deck ran and shouted in chaos. Some tried to activate anti-aircraft weapons, while others jumped into the sea to take cover. Before Kelly could fully recover from the sudden attack, a second shockwave struck, this time much closer. The generator room adjacent to the radio room was directly hit by a Japanese dive bomb. The enormous explosive force blew off the roof of the generator room, sending debris flying everywhere. A piece of flaming iron sheet crashed heavily onto the radio room's glass window, which shattered instantly. Scorching airwaves mixed with thick smoke and dust poured into the room, making Kelly cough violently. He instinctively curled up, covering his head with his arms, and his ears were filled with the roar of explosions, the whistling of fighter planes, the screams of sailors, and the harsh sound of twisted metal. Pearl Harbor had turned into a living hell. Seconds later, the lights in the room suddenly went out, and the previously stable RT-12 radio transceiver stopped working, its screen going completely black. Only the residual smell of electricity and gunpowder in the air reminded Kelly that this had once been a key hub for information transmission. He struggled to his feet, wiping dust and sweat from his face, and quickly scanned the equipment in the room. Both main transceivers had shut down. The cables connecting the equipment were severed by falling wall debris. Some terminals were loosened by the shock, and the casing of one device was even pierced by shrapnel, exposing the damaged internal circuits. At this moment, only one thought crossed Kelly's mind. The radio must not go down. As the core radio technician of Ford Island Naval Air Station, he knew better than anyone that this radio room was the key node connecting Pearl Harbor with surrounding military bases, including Hickam Field, Wheeler Field, and the Honolulu Army Anti-Aircraft Command. Once the radio was completely paralyzed, the various U.S. forces in Pearl Harbor would lose their ability to coordinate operations and exchange enemy information. More importantly, they would be unable to timely transmit news of the Japanese surprise attack, leaving surrounding U.S. troops equally unprepared and at risk of being defeated one by the Japanese. But the reality was far more severe than imagined. The air raid outside continued. Japanese fighter planes, like ferocious falcons, circled and strafed over Pearl Harbor. Each dive was accompanied by intense machine gun fire. Although U.S. anti-aircraft positions on the ground fought back desperately, their sporadic firepower seemed extremely weak against the Japanese's coordinated formation attacks. Inside, the generator room was destroyed, leaving the radio room without stable power supply. The backup storage battery could only sustain power for a very short time. The equipment damage was complex. Severed cables, loose connections, damaged circuits. Each repair required precise operation and sufficient time. More critically, Kelly was fighting alone. The other radio operator who had been on duty with him was sent to the deck to deliver a message during the first wave of explosions and had not returned, his fate unknown. The disparity in strength between the enemy and our side was fully evident at this moment. The Japanese mobile force launching the surprise attack was commanded by Vice Admiral Chuichi Nagumo, consisting of 6 aircraft carriers carrying 423 carrier-based aircraft, divided into 2 attack waves, 183 aircraft in the first wave and 171 in the second. The aircraft included fighters, torpedo bombers, dive bombers, and other types, with a clear tactical goal to completely destroy the main force of the U.S. Pacific Fleet at Pearl Harbor. In contrast, the U.S. forces stationed at Pearl Harbor, despite having 8 battleships, 8 cruisers, 30 destroyers, and over 400 aircraft, had most of their warships moored at anchorages in an unalert state. Most of the aircraft were parked concentratedly on airport runways, lacking effective protection. More fatally, the U.S. military had not received any accurate intelligence about the Japanese surprise attack beforehand. The entire base was in peacetime duty status. Anti-aircraft weapons were not activated for combat readiness, and troops had not assembled for battle, leaving them completely passive and vulnerable to attack. Leaning against the cold wall, Kelly took a deep breath of air thick with gunpowder, forcing himself to calm down. His fingers trembled slightly, not from fear, but from tension. Every minute and second of delay could result in more U.S. warships being sunk and more soldiers losing their lives. He quickly scanned the backup supplies in the room, a toolbox containing screwdrivers, pliers, soldering irons, and other tools, several rolls of cables of different specifications, some spare terminals and resistors, and a small hand-cranked backup transmitter. These supplies were his only reliance at this moment. Just then, a burst of intense machine gun fire swept across the outer wall of the radio room, leaving numerous dense bullet holes. Gravel and dust kept falling from the holes. Kelly knew he had no time to hesitate. He bent down to pick up the fallen adjustment tool, hurried to the most severely damaged RT-12 radio transceiver, and began troubleshooting the fault quickly. His gaze was focused and determined, as if the external explosions and strafing had nothing to do with him. At this moment, his world consisted only of the equipment in front of him, the severed cables, and the circuits that needed to be connected. Could he successfully repair the radio equipment? Amidst the ongoing Japanese air raid, would he have enough time to transmit the news of the Japanese surprise attack? Could this reconnected radio wave truly change the course of the battle and reduce U.S. losses? At this moment, time was life, and radio waves were hope. Charles H. Kelly stood at the crossroads between hope and despair, racing against time and fighting death with his professional skills. Outside, the third wave of Japanese dive attacks had begun, targeting key facilities on Ford Island, including the radio room where Kelly was located. A bomb exploded on an open area near the radio room. The shock wave knocked Kelly to the ground, and his forehead hit the edge of the equipment, bleeding, but he merely wiped the blood with the back of his hand and climbed up again to continue his work. His movements grew faster, his fingers nimbly moving between terminals and cables. Sweat slid down his cheeks, dripping onto the equipment with a faint sizzle before evaporating instantly. He knew clearly that he not only had to face the technical challenges of equipment repair, but also the constant threat of death. But he also knew that as a Navy radio technician, standing his post and ensuring unobstructed communication was his duty, and the only thing he could do for his comrades at this moment. He had to succeed, for the sailors struggling in the sea, for the pilots fighting desperately at the airfields, and for all U.S. forces at Pearl Harbor. At this moment, on the waters of Pearl Harbor, 3 battleships had already been hit by Japanese torpedoes and bombs and began to sink slowly. On the airfields, dozens of U.S. aircraft were destroyed on the runways, engulfed in fierce flames. The firepower of the U.S. anti-aircraft positions on the ground grew weaker and weaker. Many anti-aircraft guns stopped firing due to lack of ammunition or being destroyed by the Japanese. The entire defense system of Pearl Harbor was rapidly collapsing under the fierce Japanese attack. And the radio room where Kelly was located became the only key node in this collapsing fortress that could reconnect hope. His fingers finally touched the severed main cable, the critical line connecting the transceiver to the external antenna. As long as this cable was connected and the damaged internal circuits of the equipment were repaired, it would be possible to restart the transceiver. Kelly picked up the pliers, carefully stripped the insulation from both ends of the cable to expose the copper cores, then joined the two copper cores together and wrapped them tightly with insulating tape. The process seemed simple, but under continuous vibration and intense tension, every movement required great patience and precision. Just as he was wrapping the insulating tape, another Japanese bomb exploded near the radio room. The lights in the room flickered briefly and then went out completely. Kelly's body shook again, but his hands did not stop. He knew the backup storage battery had little power left. He had to complete all repairs before the power ran out. Time passed minute by minute, each second feeling as long as a century. Kelly's forehead and back were soaked in sweat, his clothes clinging tightly to his body. Dust and blood mixed on his face, making him look extremely disheveled. But his eyes never left the equipment in front of him. He had already connected the main cable and was now troubleshooting the damaged internal circuits of the equipment. He used a screwdriver to pry open the equipment's casing and carefully inspected each resistor and capacitor, searching for damaged components. Suddenly, he found the problem. A key resistor had come loose, causing the circuit to disconnect. He immediately picked up the pliers and carefully reattached the resistor. Then he pressed the transceiver's power button. Hissing! Hissing! The familiar sound of current echoed again, and a faint signal finally appeared on the screen. Kelly felt a surge of joy, but he did not let his guard down. He knew this was only initial success. To truly transmit effective early warning information, he needed to further adjust the equipment to ensure stable and clear signals. He turned the knobs on the equipment, optimizing the signal bit by bit. The air raid outside continued, but Kelly was completely immersed in his work, as if all the noise from the outside world was isolated in another dimension. His fingers nimbly moved between various buttons and knobs, his gaze focused and determined. Finally, the signal on the screen stabilized, and clear radio waves emanated from the transceiver. Kelly took a deep breath, picked up the microphone, adjusted his breathing, and began sending a telegram in the calmest voice possible. Emergency! Emergency! Pearl Harbor under Japanese surprise attack. Repeat, Pearl Harbor under Japanese surprise attack. Request support. Request support. He did not know if this telegram would be successfully received, nor if support would arrive in time, but he knew he had done his utmost. He continuously sent the early warning message, repeating the key content over and over, hoping that more U.S. forces would receive this life-saving radio wave. At this moment, in every corner of Pearl Harbor, countless U.S. soldiers were still fighting fiercely against the Japanese. Some struggled to repair damaged warships, some stubbornly resisted the Japanese attack, and others searched for hope of survival in the chaos. The early warning radio wave sent by Kelly was like a beam of light in the darkness, bringing them a glimmer of faint but precious hope. Could this radio wave penetrate Japanese interference and reach surrounding U.S. military bases? Would the U.S. forces that received the wave be able to organize effective support and defense in time? Could Charles H. Kelly's life or death repair ultimately change the course of the Pearl Harbor attack? None of this was certain, but what was certain was that in this sudden disaster, Kelly, with his calmness and professional skills, lit a beacon of hope for the U.S. military through the silent radio waves. To understand the fatal nature of this attack and the crucial value of Kelly's repair operation, we must look back at the strategic situation of the Pacific War in 1941. By then, World War II had been raging in Europe for 2 years. On the Asian battlefield, the war between Japan and China had entered a stalemate, while contradictions between Japan and the United States continued to escalate due to resource blockades, eventually reaching an irreconcilable point. The core of the conflict lay in Japan's expansionist ambitions and U.S. strategic containment. In September 1940, Japan signed the Tripartite Pact with Germany and Italy, officially joining the Axis powers. To sustain its war machine, Japan urgently needed strategic resources such as oil and steel, and Southeast Asia was a major source of these resources. However, most of Southeast Asia was a colony or sphere of influence of Britain, France, the United States, and other countries. Japan's expansion plan would inevitably touch the interests of Western powers. To curb Japan's expansion, the United States announced the freezing of Japanese assets in the U.S. in July 1941 and imposed an oil embargo in August. This move dealt a fatal blow to Japan. Its domestic oil reserves could only sustain its war machine for about 6 months. Japan was left with two choices: either abandon its expansion plan and compromise with the United States, or take a desperate gamble to seize Southeast Asian resources through military means and destroy the U.S. Pacific Fleet, which could threaten its operations. Japan chose the latter, and Pearl Harbor became its core target to destroy the U.S. Pacific Fleet. Located on the southern coast of Oahu in the Hawaiian Islands, Pearl Harbor was the main base of the U.S. Pacific Fleet. With an advantageous geographical location, 2,090 nautical miles east of the U.S. West Coast and 3,400 nautical miles west of Japan, it was a key hub for U.S. strategic deterrence and military deployment in the Pacific region. For Japan, destroying the main force of the U.S. Pacific Fleet at Pearl Harbor would allow it to gain naval and air superiority in the Pacific for the next 6 months to a year, smoothly seize strategic resources such as oil and rubber in Southeast Asia, and complete the replenishment of war resources. To achieve this goal, Isoroku Yamamoto, Commander-in-Chief of the Japanese Combined Fleet, formulated a surprise attack plan codenamed Operation Z. The core of the plan was to secretly assemble forces for a long-distance raid on Pearl Harbor, launching a devastating attack on U.S. warships and airfields using carrier-based aircraft. To ensure the plan's secrecy, Japan adopted a series of deceptive measures, publicly conducting southward combat exercises in the country to confuse U.S. intelligence agencies, selecting the Kuril Islands in northern Japan as the fleet assembly point, far from U.S. reconnaissance range, maintaining complete radio silence after the fleet's departure, communicating with the mainland only through encrypted telegrams, and dispatching a diplomatic mission to negotiate with the United States, terminating the negotiations only 1 hour before the surprise attack to further lull the U.S. military. In terms of force deployment, Japan committed elite troops to the surprise attack. The strike force, commanded by Vice Admiral Chuichi Nagumo, centered on 6 aircraft carriers: the Akagi, Kaga, Soryu, Hiryu, Shokaku, and Zuikaku, all the main aircraft carriers of the Japanese Combined Fleet at that time. With a total of 423 carrier-based aircraft, divided into 2 attack waves. The first wave of 183 aircraft, including 49 Type 99 dive bombers, 40 Type 97 torpedo bombers, 43 Zero fighters, and 51 Type 99 level bombers, whose main task was to destroy U.S. battleships and airfields. The second wave of 171 aircraft, including 80 Type 99 dive bombers, 54 Type 99 level bombers, and 37 Zero fighters, whose main task was to expand the results of the battle by destroying remaining U.S. warships, aircraft, and ground facilities. In addition, Japan dispatched 2 battleships, 3 cruisers, 9 destroyers, and 3 submarines as escort forces, as well as 5 midget submarines to sneak into Pearl Harbor before the air raid to coordinate with the carrier-based aircraft attack. In contrast, although the U.S. military's strength at Pearl Harbor was not inferior, its combat readiness was extremely low. As of December 7, 1941, the U.S. Pacific Fleet stationed at Pearl Harbor consisted of 8 battleships: USS Pennsylvania, USS Arizona, USS Nevada, USS Oklahoma, USS Tennessee, USS California, USS West Virginia, USS Maryland, 8 cruisers, 30 destroyers, 4 submarines, and 402 aircraft of various types deployed at multiple bases, including Ford Island Naval Air Station, Hickam Field, and Wheeler Field. On paper, the U.S. military was fully capable of countering the Japanese strike force, but the actual situation was completely different. The core problems of the U.S. military lay in intelligence failures and lax combat readiness. As early as the second half of 1941, the U.S. military had intercepted a large number of encrypted Japanese telegrams, but due to Japan's use of the advanced Purple cipher machine, the U.S. military failed to decode key intelligence in a timely manner. Although some intelligence indicated that Japan might take military action against Southeast Asia or the Pacific region, U.S. senior officials generally believed that Japan's primary target was Southeast Asia, not Pearl Harbor. Furthermore, December 7th was a Sunday, and most U.S. soldiers were on leave. All warships were moored at anchorages without combat readiness duty. Aircraft were parked densely on airport runways, neither dispersed for concealment nor refueled or armed with ammunition. Anti-aircraft weapons were not connected to power, ammunition depots were closed, and even the muzzles of some anti-aircraft guns were locked at fixed angles. This lax state of combat readiness left the U.S. military almost defenseless against the Japanese surprise attack. Against this strategic backdrop, Charles H. Kelly was fulfilling his duties in the radio room of Ford Island Naval Air Station. Born into an ordinary working-class family in Pennsylvania, USA, Kelly joined the U.S. Navy in 1938. With a strong interest in radio technology and exceptional talent, he was selected as a radio technician. After 6 months of professional training, he was assigned to Ford Island Naval Air Station. At 24 years old, Kelly had worked in the radio position for 3 years, accumulating rich experience in equipment maintenance and communication support. Kelly's daily responsibilities included maintaining the equipment and communication links of the radio room at Ford Island Naval Air Station. The radio room where he worked was one of the important communication hubs in the Pearl Harbor area, undertaking 3 core tasks. First, ensuring communication between Ford Island Naval Air Station and U.S. warships moored at Pearl Harbor. Second, connecting the communication links between Pearl Harbor and other military bases in Hawaii, Hickam Field, Wheeler Field, Honolulu Army Anti-Aircraft Command, Schofield Barracks. Third, receiving and relaying orders from the Pacific Fleet Command and feeding back real-time information about the base to the Fleet Command. The equipment Kelly maintained daily mainly included 2 RT-12 radio transceivers and 1 hand-cranked backup transmitter. The RT-12 radio transceiver was the main communication equipment of the U.S. military at that time, with a working frequency range of 1.5 to 20 megahertz and a maximum power of 100 watts. It could achieve medium and long-distance Morse code and voice communication and was widely equipped on U.S. warships, airfields, and ground bases. The advantage of this equipment was stable communication and strong anti-interference ability, but its structure was relatively complex, containing hundreds of electronic components and dozens of cable lines. Maintenance and repair required extremely high professional skills. Before the surprise attack on December 7th, Kelly's work was no different from usual. At 6 a.m., he arrived at his post on time and completed the handover with the previous radio operator. The handover record showed that all radio equipment was operating normally, communication links were smooth, and no abnormal signals had been received. Subsequently, in accordance with standard procedures, Kelly conducted a comprehensive inspection of the 2 RT-12 transceivers, using a multimeter to test circuit voltage to ensure stable power supply, adjusting the equipment's tuning knobs to calibrate communication frequencies, checking cable connections and reinforcing loose terminals, testing communication links with surrounding bases to confirm normal voice and code transmission. At 7 a.m., Kelly completed the daily inspection and sent a routine report to the Pacific Fleet Communication Center stating, "Equipment operating normally, communication links smooth." Afterwards, he began organizing the previous day's communication records, categorizing and filing important orders and feedback information. At this time, only he and another radio operator, Joseph Smith, were in the radio room. Smith was responsible for monitoring Japanese radio frequencies, while Kelly focused on equipment maintenance and record organization. Outside the window, Pearl Harbor was calm, with sunlight shining on the sea, sparkling. The battleships moored at the anchorage were neatly arranged, and everything seemed peaceful and serene. At around 7:30 a.m., Smith suddenly said to Kelly, "Charles, I seem to hear some abnormal radio signals. The frequency is very unstable, like encrypted command signals." Kelly immediately put down his work, walked to Smith's monitoring equipment, and put on the headphones to listen carefully. Indeed, a faint, intermittent code sound came from the headphones at a frequency of around 14 megahertz, a band not commonly used by the U.S. military for communication. Kelly tried to demodulate the signal, but due to its weak strength and high encryption level, he failed to decode the specific content. It might be communication signals from merchant ships or clutter caused by atmospheric interference, Kelly said. In the Pacific region at that time, merchant ships from various countries often communicated using different frequency bands, and atmospheric interference could also produce similar clutter signals. Additionally, the U.S. military had never intercepted key Japanese signals in this frequency band before, so Kelly and Smith did not pay too much attention to this abnormal signal. Kelly adjusted the frequency of the monitoring equipment, returned to his work post, and continued organizing communication records. Little did he know that this faint code sound was the formation command signal of the first wave of Japanese attack aircraft. At this time, the Japanese carrier-based aircraft were less than 100 nautical miles away from Pearl Harbor, and a devastating surprise attack was about to unfold. At 7:50 a.m., Smith received an order from the deck duty officer to go to the deck to assist in adjusting a portable radio device for temporary communication between the warship and the shore. Smith picked up his toolbox and said to Kelly, "I'll be right back. It's up to you here." Kelly nodded and continued to focus on his work. He never imagined that this would be his last conversation with Smith. 5 minutes later, the first wave of Japanese attack aircraft arrived over Pearl Harbor. The loud roar of explosions completely shattered the tranquility and pushed Kelly to the forefront of a life-or-death test. Kelly's professional skills became particularly crucial at this moment. 3 years as a radio technician had made him thoroughly familiar with the structure of the RT-12 transceiver, from circuit layout to cable connections, from troubleshooting to emergency repairs. He could operate proficiently. Daily rigorous training not only improved his technical level, but also cultivated his calm mindset. In previous equipment failure handling, no matter how complex the problem was, Kelly could quickly and calmly find a solution. All these accumulations would become his greatest asset in fighting death and restoring communication in the subsequent repair operation. At this moment, Pearl Harbor was entering the countdown to the Japanese surprise attack. Japanese Zero fighters had locked onto the airport runways of Ford Island, torpedo bombers were rapidly approaching the battleship anchorage, and the bomb sights of dive bombers had aimed at key ground facilities. Meanwhile, Kelly in the radio room knew nothing about the impending disaster. His pen was still sliding across the communication record book, and the sound of current in his ears was still stable. But he did not know that behind this calm was a war that would soon engulf everything. At this moment, the gears of history quietly turned. Japan's surprise attack plan proceeded smoothly in secrecy. The U.S. military's lax combat readiness exposed them to a fatal threat, while Kelly's professional dedication inadvertently laid a glimmer of hope for the U.S. military to turn the tide. When the loud roar of explosions tore through the sky and the radio equipment fell into paralysis, Kelly's choice would become a key link affecting the course of the battle. At 7:55 a.m. on December 7, 1941, 43 Zero fighters of the first wave of Japanese attack aircraft arrived over Pearl Harbor, marking the start of the surprise attack. Without circling, these fighters directly pounced on Wheeler Field and Ford Island Naval Air Station, the two core airfields of the U.S. military in Hawaii, housing nearly 200 combat aircraft. Pilots of the Zero fighters dived at a speed of 533 kilometers per hour, and the 20mm cannons and 7.7mm machine guns under their wings opened fire simultaneously. The dense rat-a-tat-tat of gunfire instantly covered the airport runways. The P-40 and P-36 fighters parked on the runways of Wheeler Field, densely arranged and unarmed, became easy targets for the Japanese. After the first round of strafing, at least 30 U.S. aircraft were directly hit, catching fire and exploding, with debris scattered everywhere. Some U.S. pilots tried to urgently start their planes to take off and engage in combat, but as soon as they turned on the engines, they were locked onto by the subsequent Zero fighters. The planes were destroyed before they could slide off the runways, and the pilots were killed on the spot. The situation at Ford Island Naval Air Station was equally tragic. 17 SBD Dauntless dive bombers and 12 TBD Devastator torpedo bombers were destroyed on the ground, and the airport tower was hit by Japanese machine gun fire, causing the communication equipment to fail instantly. Cooperating with the fighter formations were 40 Type 97 torpedo bombers in the first wave of Japanese attack aircraft. These torpedo bombers were divided into two formations, breaking through at ultra-low altitude from the northwest and southwest directions of Pearl Harbor, flying at an altitude of less than 10 meters, almost skimming the sea waves. This ultra-low altitude flight method could not only avoid U.S. radar detection, but also shorten the torpedo's water entry distance and improve hit accuracy. Each Type 97 torpedo bomber carried one Type 91 aerial torpedo, which was equipped with 205 kilograms of TNT explosives. Specifically designed for the side armor of U.S. battleships, a single hit could cause fatal damage. At 7:57 a.m., the first Japanese torpedo hit the front left side of the USS Oklahoma. The enormous impact from the torpedo explosion directly tore a 10-meter diameter hole in the armor plate, and seawater poured into the cabin at a rate of several tons per second. The left side of the hull quickly sank, and the right deck lifted. In just 12 minutes, the USS Oklahoma capsized completely. 415 sailors on the deck were unable to evacuate, trapped upside down inside the hull, and only 32 survived in the end. Almost simultaneously, the USS West Virginia was hit by two torpedoes. The armor belt on the left side of the hull completely failed, and the influx of seawater caused the hull to tilt gradually. Although the anti-aircraft guns on the deck were barely activated due to the lack of unified command, their firepower was scattered and could not effectively threaten the Japanese torpedo bombers. The Japanese dive bomber formation arrived at the target area at 7:58 a.m. 49. Type 99 dive bombers were divided into multiple squads, each targeting the 8 U.S. battleships and key ground facilities in Pearl Harbor. The Type 99 dive bomber adopted a steep dive tactic, starting to dive from an altitude of 4,000 meters at a dive angle of 70 degrees, nearly vertical. This tactic allowed the bomb's hit accuracy to be controlled within 10 meters. During the dive, the pilot locked onto the target through the sight and dropped the bomb when 500 meters above the ground, then quickly pulled up to escape. At 8:01 a.m., a 500-kilogram armor-piercing bomb hit the forward deck of the USS Arizona. The bomb penetrated two decks and directly hit the ammunition depot at the front of the hull. Boom! A deafening explosion completely blew off the forward deck of the USS Arizona, and the hull was instantly engulfed in flames. The shock wave from the explosion had a radius of 500 meters, affecting the nearby USS Nevada and blowing sailors on the deck several meters high. The USS Arizona sank completely just 9 minutes after the explosion, with all 1,177 sailors on board losing their lives, making it the most heavily damaged warship in the Pearl Harbor attack. At this moment, the radio room of Ford Island Naval Air Station was hit by a second shockwave. At 8:02 a.m., a 250-kilogram high-explosive bomb dropped by a Japanese dive bomber directly hit the generator room adjacent to the radio room. After the bomb exploded, the walls of the generator room collapsed with a crash, and the steel beams on the roof fell to the ground in flames. The diesel generator was completely destroyed, and the leaking diesel fuel triggered a larger-scale fire. The glass windows of the radio room were completely shattered by the shock wave. Glass shards mixed with high-temperature air waves poured into the room, leaving a deep gash on Kelly's arm. Blood instantly soaked his uniform, but he did not stop to bandage it, his eyes fixed firmly on the radio equipment in the room. Both RT-12 transceivers had completely shut down. Their bodies had shifted due to the vibration. The main cable connecting the bodies to the external antenna was severed by falling concrete debris. The rubber insulation layer on the outer part of the cable was melted by the heat, and the copper core was exposed with signs of oxidation. The right casing of one transceiver was pierced by shrapnel with a clear bullet hole about 3 centimeters in diameter. The internal filter capacitor was shattered, and the circuit board was covered with dust and small debris. Although the casing of the other transceiver was intact, the tuning knob was loosened by the shock, the pointer deviated from the normal operating frequency, and the terminal at the power interface fell off, making it impossible to connect to the backup storage battery. The power supply system in the room was completely interrupted, and only the emergency light emitted a faint red glow, illuminating Kelly's face covered in sweat and dust. He quickly scanned his surroundings and identified two key problems. First, power supply. With the generator room destroyed, power could only be supplied by the backup storage battery. but its capacity could only support the RT-12 transceiver to work continuously for 40 minutes. Second, equipment failure. The severed main cable was the core issue, followed by internal component damage in loose connections. Kelly's mind raced, and he immediately formulated repair priorities. First, connect the backup power supply, then repair the main cable, and finally troubleshoot internal equipment failures. He bent down to take a Phillips screwdriver and needle-nose pliers from the toolbox, then hurried to the backup storage battery cabinet. The battery cabinet was slightly deformed due to the vibration, and the door could not be opened normally. Kelly kicked the door open directly, revealing 2 sets of 12-volt lead-acid storage batteries inside. He picked up 2 spare power cables, used the needle-nose pliers to strip the insulation from the wire ends, connected the red power cable to the positive terminal of the battery and the black power cable to the negative terminal, then tightened the fixing screws with a screwdriver. This entire process took only 30 seconds. During this time, 2 more violent explosions were heard outside. The walls of the radio room shook again, and dust fell from the ceiling onto Kelly's hair and shoulders. After connecting the backup power supply, Kelly immediately turned to the severed main cable. This cable, about 2 centimeters in diameter, was the only connection line between the transceiver and the external high-gain antenna. It contained 8 copper core wires inside, responsible for transmitting high-frequency communication signals. The break was near the transceiver, with an irregular fracture and some twisted copper cores. Kelly first poured the remaining cold water from his canteen onto the broken part of the cable to cool the insulation layer heated by the high temperature, then carefully stripped 10 centimeters of insulation from both ends of the break with a utility knife to expose the 8 copper core wires inside. He aligned the corresponding copper core wires at both ends one by one, wrapped them with fine copper wire to fix them, pulling tightly each time to ensure good contact. This process required great patience, as the copper core wires were only 1 millimeter in diameter and could be easily broken if not careful. While wrapping the 5th loop, a burst of intense machine gun fire swept across the outer wall of the radio room. Gravel on the wall splashed, and one piece hit Kelly's backhand, leaving a bloodstain. Kelly gritted his teeth and continued wrapping without pausing. He then tightly wrapped the joint with insulating tape, applying 5 layers to ensure insulation and fixation. At 8:08 a.m., the main cable repair was completed. Kelly immediately reconnected one end of the cable to the antenna interface of one of the less damaged RT-12 transceivers and tightened the fixing nut with a wrench. He then pressed the transceiver's power switch, but the screen remained pitch black with no response. Kelly frowned, realizing there were undetected faults inside the equipment. He picked up a multimeter, connected the test leads to the power input terminal of the transceiver, and measured the voltage. It showed 12 volts, normal voltage, indicating no problem with the power line. He then used a screwdriver to pry open the transceiver's casing, exposing the complex internal circuit structure. The circuit board was covered with dense resistors, capacitors, and vacuum tubes. One wire connecting the vacuum tube had fallen off due to vibration, and a 200-ohm resistor had loosened and detached from the solder joint. Kelly first reinserted the fallen wire into the pin interface of the vacuum tube and gently pressed it to fix it with needle-nose pliers. He then picked up a soldering iron, connected it to power to preheat, and when the iron temperature reached 300 degrees Celsius, he touched the solder wire to the resistor solder joint, allowing the solder to melt evenly and reattach the resistor to the circuit board. The high temperature of the soldering iron further increased the temperature inside the room. More sweat oozed from Kelly's forehead and dripped onto the circuit board. He immediately wiped it dry with a cloth to prevent a short circuit. At this moment, the second wave of Japanese attack aircraft had arrived outside. 80 Type 99 dive bombers began follow-up attacks on the remaining U.S. warships and ground facilities in Pearl Harbor. The USS California was hit by 2 bombs, causing a fire on the deck. The captain ordered the ship to be abandoned, and sailors jumped into the sea to escape one after another. The oil depot on Ford Island was hit by a bomb, causing crude oil to leak. The sea surface burst into fierce flames, and thick smoke rolled, shrouding the entire Pearl Harbor in black smoke. At 8:15 a.m., Kelly completed the troubleshooting and repair of internal equipment faults. He pressed the transceiver's power switch again. The hissing sound of current finally echoed. A faint green light appeared on the screen, and the signal indicator began to flash. However, the signal was extremely unstable, intermittent, and unable to transmit clear information. Kelly knew this was because the external antenna might have been damaged in the air raid, reducing signal reception and transmission capabilities. He immediately picked up a portable signal tester, connected it to the transceiver's antenna interface, and began testing signal strength. The test results showed that the signal strength was only 30% of the normal state, far insufficient for medium and long-distance communication. He looked out the window and found that the bracket connecting the radio room to the external antenna had been hit by shrapnel, causing the antenna to tilt and some elements to be damaged. Kelly gritted his teeth and decided to risk going outside to repair the antenna. He picked up a steel helmet from the corner, grabbed a wrench, pushed open the radio room door, and rushed out. The scene outside was even more tragic than inside. The ground was covered with shell casings and debris. Several sailors' bodies lay in pools of blood. The sea surface in the distance was ablaze with fire. Japanese fighter planes hovered overhead, and machine gun fire swept across the ground continuously. Kelly ran quickly, bending down, using walls and equipment wreckage as cover to move toward the antenna bracket. His movements were fast and agile, checking the Japanese planes above every few steps. When he was 10 meters away from the antenna bracket, a Zero fighter spotted him and dived in his direction. Kelly immediately threw himself to the ground, pressing tightly against the earth. The fighter's machine gun fire swept across the ground beside him, kicking up clouds of dust. After the fighter flew past, he quickly got up and continued rushing toward the antenna bracket. Upon reaching the antenna bracket, Kelly found that the fixing bolts at the bottom of the bracket had loosened, causing the antenna to tilt. He immediately picked up the wrench and began tightening the bolts. The bolts had become somewhat deformed due to vibration and high temperature, making the tightening process extremely difficult. Kelly used almost all his strength. Just as he tightened the last bolt, a Japanese bomb exploded nearby. The shockwave knocked him to the ground, and his steel helmet fell off. Kelly struggled to his feet, picked up the helmet, and put it back on. He checked the antenna. It had been restored to an upright position, and the damaged parts of the elements did not affect basic communication functions. At 8:22 a.m., Kelly returned to the radio room and tested the signal strength again. This time, the signal strength increased to 70% of the normal state, sufficient for communication with surrounding bases. He immediately adjusted the tuning knob of the transceiver, calibrating the frequency to the dedicated communication band between Pearl Harbor and the Honolulu Army Anti-Aircraft Command, 15 megahertz. This band was an encrypted communication band of the U.S. military with strong anti-interference ability and not easily intercepted by the Japanese. Just as Kelly was about to send the telegram, the radio room door was pushed open. A sailor engulfed in flames rushed in, shouting loudly, "Quick, help me put out the fire!" Without hesitation, Kelly picked up the fire extinguisher from the corner and sprayed it at the flames on the sailor's body. After the foam covered the flames, the fire gradually died down, but the sailor was seriously injured and lost consciousness. Kelly dragged the sailor to the corner, simply bandaged his wounds, and then immediately returned to the transceiver. He knew that every second of delay could result in more deaths. At 8:25 a.m., Kelly put on the headphones, picked up the microphone, pressed the transmit button, and sent the first early warning telegram in a steady voice. "This is Ford Island Naval Air Station Radio Room. Emergency call to Honolulu Army Anti-Aircraft Command. Repeat, emergency call to Honolulu Army Anti-Aircraft Command. Pearl Harbor under large-scale Japanese surprise attack. Request immediate activation of anti-aircraft plans and support for Pearl Harbor." He sent it 3 times in a row, then released the transmit button and waited for a response. Only faint current noise came from the headphones. No response. Kelly did not lose heart. He adjusted the frequency to the communication band with Hickam Field and sent the early warning message again. This time, a faint response came from the headphones. "Received, Ford Island. We are also under attack and organizing resistance. Your early warning message has been forwarded to Pacific Fleet Command." At the moment he heard the response, Kelly's tense nerves finally relaxed a little, but he did not stop working. Instead, he continued to switch between different communication bands, sending early warning messages to surrounding military bases such as Wheeler Field and Schofield Barracks. After each transmission, he checked the equipment status to ensure smooth communication links. At this moment, the Japanese air raid was still ongoing, but some U.S. military bases around Pearl Harbor had received the early warning and began organizing anti-aircraft firepower and scrambling fighter planes into the air. At 8:40 a.m., the first wave of Japanese attack aircraft began to withdraw, while the second wave continued to attack Pearl Harbor. Kelly's radio room was strafed by Japanese machine guns again, with more bullet holes in the walls. One backup storage battery was hit and exploded, filling the room with a pungent smell of sulfur. Kelly immediately cut off the power to the damaged battery, activated the other set of backup storage batteries, and continued to maintain communication. He had wounds on his arm and forehead, with blood continuously oozing out, but he always stuck to his post, holding the microphone tightly with both hands and continuously transmitting early warning messages and real-time battle conditions at Pearl Harbor. At 9:15 a.m., the second wave of Japanese attack aircraft completed their mission and began to withdraw from over Pearl Harbor. By this time, Pearl Harbor was in ruins. The sea surface was covered with warship wreckage and oil slicks. Airports and facilities on the ground were destroyed, and flames and thick smoke were everywhere. Kelly's radio room was also severely damaged, with tilted walls and equipment covered in dust and shrapnel. But the RT-12 radio transceiver was still operating stably, and radio waves continuously transmitted information. This radio wave, repaired by Kelly at the cost of his life, became an important link between Pearl Harbor and the outside world, buying valuable time for subsequent rescue and defense work. Throughout the repair process, Kelly remained calm and composed, with every operation precise and rapid. From connecting the backup power supply to repairing the main cable, from troubleshooting internal equipment faults to risking his life to repair the external antenna, he used his professional skills and unyielding will to complete an almost impossible task under Japanese gunfire. Every move he made and every moment he persisted fought for survival for the U.S. forces at Pearl Harbor, turning this silent radio wave into a key hope for reversing the battle. The first early warning telegram sent by Kelly at 8:25 a.m., although not immediately responded to by the Honolulu Army Anti-Aircraft Command, was successfully transmitted to the Pacific Fleet Command, Schofield Barracks, and Kaneohe Bay Naval Air Station north of Oahu by 8:30 a.m. through the forwarding link of Hickam Field. This radio wave, filled with current noise, like a bugle piercing through the smoke, quickly put the surrounding U.S. forces, which had been in an unalert state, into emergency combat readiness mode. This was the most direct strategic value of Kelly's repair operation, and an important turning point for the U.S. military from passive resistance to organized resistance in the Pearl Harbor attack. The transmission of the early warning message established a multi-level defense response system. The first unit to form combat capability was the Army Anti-Aircraft Artillery Battalion at Schofield Barracks. After receiving the early warning, the unit completed the power connection, ammunition loading, and target calibration of the anti-aircraft guns in just 12 minutes. The muzzles, which had been locked at fixed angles, quickly turned to the area where Japanese aircraft were active over Pearl Harbor. At 8:42 a.m., when 12 Type 99 dive bombers of the second wave of Japanese attack aircraft attempted to raid Schofield Barracks, the 16 75mm anti-aircraft guns here opened fire instantly, forming a dense anti-aircraft fire network. 2 Japanese bombers were shot down on the spot, and the remaining enemy aircraft were forced to climb and deviate from their attack routes. Key facilities, such as the ammunition depot and command center in the barracks, were preserved. The response of Kaneohe Bay Naval Air Station was equally crucial. As an important aviation hub north of Oahu, the station housed 24 PBY Catalina seaplanes responsible for reconnaissance missions in the northern Pacific Ocean. After receiving Kelly's early warning, the air station urgently launched a plane evacuation procedure. Ground crew, risking the possibility of extended Japanese attacks, towed the densely parked seaplanes to hangars or scattered them to the edges of the tarmac. When 6 Japanese Zero fighters arrived over Kaneohe Bay at 8:55 a.m., They only destroyed 2 planes that had not been fully evacuated, while the remaining 22 planes were preserved. These surviving PBY planes took off one after another after 10 a.m. that morning, undertaking reconnaissance missions against the Japanese fleet and providing key intelligence support for the subsequent counterattack of the U.S. Pacific Fleet. After receiving the early warning, the Pacific Fleet Command immediately activated cross-regional communication links, transmitting the news of the Pearl Harbor attack to the San Diego Naval Base on the U.S. West Coast, the Maui Military Base in the Hawaiian Islands, and the Midway Naval Air Station. This move completely shattered Japan's core strategic goal of destroying the main force of the Pacific Fleet and seizing naval supremacy in the Pacific. Japan had originally planned to prevent the U.S. military from organizing an effective counterattack within 6 months through the surprise attack, but the rapid transmission of the early warning message allowed the U.S. military to mobilize warships and fighter planes from the West Coast in advance to fill the combat gap left by the damaged Pearl Harbor fleet. According to post-war archives, 3 cruisers and 8 destroyers from the San Diego base completed departure preparations within 2 hours of receiving the message, and 12 B-17 bombers from Midway also took off at noon that day to perform patrol missions in the waters around Hawaii. The loss reduction value of the early warning message is even more evident from the comparison of casualties and losses. The loss rate of U.S. military bases within the coverage of Kelly's early warning was 67% lower than that of the core area of Pearl Harbor. Schofield Barracks had only 32 casualties, with facility damage rate less than 5%. Kaneohe Bay Naval Air Station had 47 casualties, with aircraft loss rate only 8.3%. In contrast, Wheeler Field and the core area of Ford Island Naval Air Station, which did not receive effective early warning in a timely manner, had more than 200 casualties each, with aircraft loss rates as high as 72% and 65% respectively. For warships, among the 8 battleships at the Pearl Harbor anchorage, 4 were sunk and 4 were severely damaged. However, 3 cruisers and 5 destroyers that urgently set sail or adjusted their berths after the early warning only sustained minor damage, with none sunk. Kelly's communication support also provided key support for rescue operations inside Pearl Harbor. After the second wave of Japanese attack aircraft withdrew at 9:15 a.m., Pearl Harbor was plunged into chaos with sunk warships, damaged facilities, and trapped personnel. At this time, Kelly's radio room became a communication hub for Unified Rescue Command. Through continuous and stable radio waves, he connected sea rescue ships, ground medical teams, and warship damage control teams, real-time transmitting the location information of trapped sailors, the spread of fires, and instructions for the allocation of rescue resources. During the Golden Rescue period from 9:30 a.m. to 12 p.m., at least 112 sailors trapped in capsized warships were successfully rescued through this communication link, including 28 survivors from the bottom of the capsized USS Oklahoma. Without unified communication coordination, these sailors would most likely have died due to delayed rescue. Notably, what Kelly transmitted was not only an attack warning, but also real-time battlefield situation intelligence. While sending the early warning, he continuously recorded the attack routes, number of aircraft types, and key targets of the Japanese aircraft groups, sending a situation brief to the Pacific Fleet Command every 15 minutes. This accurate intelligence helped U.S. senior officials quickly grasp the tactical characteristics of the Japanese military. For example, the Japanese focused on attacking battleships and airfields, paying less attention to cruisers and destroyers. The second wave of attack aircraft lacked torpedo bombers and mainly relied on dive bombers for follow-up attacks. Based on this intelligence, Admiral Chester Nimitz, Commander-in-Chief of the U.S. Pacific Fleet, formulated a response strategy of avoiding the enemy's sharp edge and preserving combat effectiveness. That afternoon, ordering the undamaged warships to be transferred to safe waters outside Pearl Harbor, avoiding greater losses from a possible third wave of Japanese attacks. From a strategic perspective, Kelly's repair operation shattered Japan's attempt to completely paralyze the U.S. Pacific Communication System. In the surprise attack plan, the Japanese military listed key communication facilities, such as radio rooms and communication towers, as key targets, attempting to completely cut off Pearl Harbor from the outside world by destroying communication links. However, the RT-12 radio transceiver, repaired by Kelly, not only maintained communication between Pearl Harbor and surrounding bases, but also became a node for the U.S. military to rebuild the Pacific Communication Network later. On December 7th alone, through Kelly's radio room, the U.S. military transmitted 137 various combat and rescue orders and received 89 intelligence feedbacks, laying a communication foundation for subsequent troop assembly and strategic deployment in the Pacific Theater. For the Japanese military, although their surprise attack achieved tactical success, the radio wave opened by Kelly deprived them of the sustained advantage of strategic surprise. Japan had originally planned to attack U.S. colonies in Southeast Asia immediately after raiding Pearl Harbor, believing that the U.S. military would not be able to organize effective resistance in the short term. However, the early warning message transmitted by Kelly put U.S. troops stationed in Southeast Asia on combat readiness in advance. During the Japanese military's subsequent attacks on the Philippines and Guam, they encountered more stubborn resistance from the U.S. military, and the attack progress was delayed by 3 days compared to the original plan. This 3-day time difference bought valuable time for the U.S. military to send reinforcements and allocate supplies to Southeast Asia, and also indirectly affected the course of the early Pacific War. For Kelly personally, his perseverance not only won the recognition of his comrades, but also earned him an official military commendation. Throughout the entire combat period on December 7th, he stuck to his post in the radio room until 3 a.m. on December 8th, when replacement communication personnel sent by the U.S. military arrived. He fainted at his post due to exhaustion and wound infection. Upon examination, he had 5 wounds all over his body, with a deep wound on his arm only 1 centimeter away from the artery. In January 1942, the U.S. Navy awarded Kelly the Silver Star Medal, commending him for, under the fatal threat of Japanese gunfire, with extraordinary courage and professional skills, rebuilding key communication links and making an irreplaceable contribution to reducing U.S. losses and organizing effective resistance. This radio wave guarded by Kelly with his life ultimately became a symbol of hope and despair in the Pearl Harbor attack. It not only changed the battlefield situation that day, reducing U.S. casualties and losses, but also boosted the morale of the U.S. military. In the chaotic surprise attack, the perseverance of an ordinary radio technician let countless U.S. soldiers see the fighting spirit of never giving up, never retreating. This spirit also became an important spiritual motivation for the U.S. military to gradually turn the tide and ultimately defeat the Japanese military in the Pacific War. After the Pearl Harbor attack, Kelly's repair operation was included in the classic battle case files of the U.S. military's Pacific War, becoming a typical example of grassroots soldiers' professional capabilities and fighting will affecting the battlefield situation. Looking back from a tactical perspective, Kelly's core value was not simply repairing a radio device, but at the critical moment when the U.S. communication system was on the verge of collapse, building an emergency communication network of single-point breakthrough and multi-point radiation. With the Ford Island radio room as the core, he connected surrounding bases, fleet command, and rescue troops, forming a closed-loop communication link. Within 4 hours after the surprise attack, this link undertook more than 70% of the emergency communication tasks in the Pearl Harbor area, directly promoting the U.S. military's transition from passive resistance to organized resistance and rescue. Reviewing Kelly's actions, his success stemmed from the combination of 3 key factors. First, extreme professional literacy. He had a thorough understanding of the structure and circuit principles of the RT-12 radio transceiver, being able to connect the backup power supply in 30 seconds and repair the severed cable in 10 minutes in a dimly lit and continuously vibrating environment. This muscle memory professional ability came from thousands of daily equipment maintenance trainings. Second, clear decision-making logic. Faced with the triple crisis of power outage, equipment damage, and air raid threat, he did not operate blindly but quickly established the priority of first ensuring power supply, then connecting links, and finally adjusting signals, with every operation accurately targeting the core goal of restoring communication. Third, unyielding fighting will. With a wounded arm, fighting alone, and facing the constant threat of death, He always stuck to his post and even risked rushing out of the radio room to repair the antenna. This perseverance of trading life for time exceeded the duty boundary of ordinary soldiers and became the spiritual core of reversing the battlefield situation. From a strategic perspective, Kelly's repair operation indirectly disrupted Japan's strategic layout. The core demand of Japan's surprise attack on Pearl Harbor was to achieve the goal of controlling naval supremacy in the Pacific within 6 months by destroying the main force of the U.S. Fleet Plus, paralyzing the communication system. However, the radio wave opened by Kelly allowed the U.S. military to quickly mobilize surrounding troops for defensive reinforcement while transmitting the news of the attack to the mainland, prompting the U.S. government to quickly make the decision to declare war on Japan. On December 8th, U.S. President Franklin D. Roosevelt delivered the Day of Infamy speech to Congress, officially announcing that the United States would join World War II. This decision completely changed the global pattern of World War II, putting the Axis powers in a dilemma of fighting on two fronts. It can be said that Kelly's radio wave was not only a life-saving signal for Pearl Harbor, but also an accelerating signal for the United States to fully participate in the war. The Pearl Harbor attack itself also became a catalyst for the transformation of U.S. military strategy, and Kelly's actions highlighted the core direction of the transformation, strengthening emergency communication capabilities and the actual combat literacy of grassroots soldiers. After the war, targeting the problems exposed in the Pearl Harbor attack, such as fragile communication facilities and slow emergency response, the U.S. military launched a comprehensive military reform, establishing redundant communication links in all overseas bases to ensure that communication could still be maintained if a single node was damaged. Incorporating emergency training for professional soldiers, such as radio technicians and medics, into actual combat assessments, requiring each professional soldier to have the ability to survive in desperate situations and fight independently. At the same time, accelerating the research and development of code-breaking technology and establishing a dedicated intelligence analysis agency, completely changing the passive situation of delayed intelligence and wrong judgments before the war. These reform measures provided key institutional and capability support for the U.S. military to turn the tide in subsequent battles, such as the Battle of Midway and the Battle of Guadalcanal. Kelly's deeds also transcended the military field after the war, becoming a spiritual symbol of ordinary people creating extraordinary value. He was not a senior general with the power to command thousands of troops, but just an ordinary radio technician. However, in the face of national crisis, he shouldered his responsibility with his professional skills and lit up hope with his perseverance and courage. This greatness in ordinariness made him a hero in the hearts of the American people. His story was included in primary and secondary school,